chapter 11. The first one, the question says this is written as log n equals -3. And since there is no base here, it is understood to be 10. So our base is 10, our argument is n, and our exponent is going to be -3. Then it says to rewrite in exponential form. So I write the 10 as the base, the exponent is -3, the argument is n. And then in number C, part C, it says solve that. Well, what have we learned? When you have 10 to the -3rd, what does that really mean? It really means that this says, hey, go down to the denominator, and since there's nothing left up top, it becomes 1 over 10 to the 10 to the 3rd, no negative anymore. 10 to the 3rd means 10 times 10 times 10, which is 1,000. So it's 1,000th, or as a decimal, this is also 1,000ths. So either of these two answers, especially if it's multiple choice, you're going to be looking for either of those two answers. All right. Problem 2 says, again, rewrite in exponential. So again, when I have log n 8th root of 32 equals 5/8. This is my base, this is my exponent, this is my argument. So n to the 5/8 equals 8th root of 32. It then says to solve the equation. So the first thing I did from here to here was I changed this form. This is in radical form. I changed it to power form. I believe that's from chapter 9. And then once I changed it, then once I change it, I now need this to have, if I know I'm looking for the base here, I know this exponent has to be 5/8. This exponent over here has to be 5/8, and I'm trying to look for the base. So I'm going to try to rewrite this 32 any way that I can. When I rewrite it here, I look and I go, oh, that's good. I've got an 8 in my denominator and an 8 in my denominator, so I need the 5 up here. But what's the only way I can get 1/8 to become 5/8 is when you have a power to a power, you multiply the two powers together. So what happens is, I go, oh, I can rewrite 32 as 2 to the 5th. And then again, right here, I have that power to a power, 5 over 1 times 1/8. Top times top becomes 5 over 1 times 8 is 8. And so that's how I get the 5/8. So now I've got the 5/8 to match. Now I know that the bases have to be the same, so n must equal 2. All right, number 3. It says consider this log. So the first thing I do is I break this down. When I have division of these two guys, I know that that means subtraction. So the first thing I did is I broke this apart from this guy. And when I did that, this became a subtraction because of this division. Notice that's the top part and that's the bottom part. After that, I then work on this guy individually, and I work on this guy individually. Technically, this log is in parentheses like that, and that does make a difference because notice right here, there's a couple things I want you to see. When I broke this out, yes, this is addition. When I break this out, yes, it should be addition, but it would look like this. So here's a little step that I probably should have wrote in there. This would become a negative log 5 of 5 plus log 5 of y to the 4th. Well, when I do that, this negative sign distributes to here and to here, and so it makes them both become subtraction. So that's why both of those are subtractions. Yes, I know when I break it out, it should become a plus, but this subtraction sign right here distributes to both of them, and that's why that became a negative. And then another thing I want you to notice, and this is one of our rules we talked about, when you have the same base to the same argument, that turns into 1. Because remember, 5 to the what power equals 5? That the question right here, this one right here, is really log 5 equals x. If I change it to exponential, 5 to what power equals 5? And you know that x has to equal 1. So that means that log 5 to the argument 5 is just a 1. So that's where I replace that with that. So anytime you see that kind of happen, you need to make sure that you rewrite that in. And that should be everything for number 3. Number 4 is asking you to go the opposite way, to put everything back. So the first thing I do is I bring the 2, and it's going to belong to here and to here. This doesn't have an exponent, so I just left it the same. Notice I should keep these guys in parentheses, because it's this whole thing eventually will be added to this whole thing. So first thing, I then take this and I make it, when you have adding them, or I'm sorry, when I have these guys, these two guys are subtracted, I can write that as the division of this and this. So when I do that, it became this plus, and when I have this subtraction, this also becomes z divided by 9. Remember, it is not ln of z divided by ln of 9. That is completely different. No, when you have this and you smash them together, it's the ln of z divided by 9. This divided by that. Now when I have this right here, same base, ln and ln, and I'm adding the 2, I can multiply these guys, and what happens is you get 9 over z squared times z over 9. You can cross cancel because of fractions. You can cross simplify. This 9 and 9 go away. One of these z's goes away. This whole z goes away, but only one of these z's goes away, so I have one z left, and so that's why it becomes, in my top, that cancels to a 1 and a 1. 1 times 1 is 1 over z times 1 is just z, and so that's where this z 1 over z came from. Number 5 asks you to solve the equation by using equivalent base and setting it. So this one, on part A, you have to do this way. You can solve it a different way, which is part B, but if you don't do A the correct way, it will be marked off. I want you to try both ways. The first way, I'm not using change of base. In the first way, I'm going to I know that this base has to be the same as this base, so I break it down, and I know this is really 5 squared, and I know this is really 5 to the 4th. Once I get them to have the same base, I know that this exponent has to be equivalent to this exponent. Because 5 to some power has to be the same as 5 to the 4th, that means that this, when I simplify, has to be 4, because 5 to the 4th is only going to equal 5 to the 4th. You're not going to have any other way of making that equivalent. So right here, I distributed this guy, that's how I got this, and I say, okay, I know this has to equal to that. So I set them equal, and all I did is basic algebra here. Added 6 to both sides, divide by 4, you get x equals 5 halves. Now over here in part B, now it says to go ahead and do the change of base formula. So what I do is I go, okay, I'm going to go right away from exponential form to log form. Once I go log form, my argument goes in the top, my base goes in the bottom, and I change of base that. Now it's log 10, so I can use this and put this in the calculator. So I actually put that in the calculator. Remember to hit in the calculator. You hit 625, then log, then divided by, then hit 25, log, and then make sure you hit equals. And when you hit equals, you will get 2. That is for the calculator that we use in class, not for the other scientific calculators. Only for the ones I use in my class. And then again, basic algebra starts to rule. I add 3, divide by 2. And you notice that this answer right here is the same as this answer because they should work out to do that. Number 6. Number 6 says, consider it. It says it's asked you to solve this. So when I go to solve this, I know my problem is I've got a log and a log. I want to get that to at least just a singular log, and I can do that because they both have base 3. So what happens when I'm adding them, we've learned our rules, I can multiply these two guys and write it as a single logarithm. So it can become log base 3, x minus 2 times x plus 2, and that still equals 4. I can then distribute this out. X times x is x squared. X times this is plus 2x. This is a negative 2x. And this right here is a minus 4. It's a difference of squares, so I know the middle cancels out. X squared minus 4. Hopefully you know that faster. You don't have to do all this distributing. If you can recognize right away that's a difference of squares, you know it's going to be this squared minus these two numbers. So x squared minus 4. And that equals 4. Well then, right here when I get to single log, I go, you know what, my problem is I need to get to this x. The only way I'm going to be able to get to that is if I change it to exponential form. So right here, I change it to exponential. 3 to the 4th power equals all of that. Well, 3 to the 4th power is really 81. I then need to get, since this right here is the problem we've talked about. How many x's do I have to different powers? Only one. You only have x squared. You don't have plus x or anything. So I can get everything away from that x squared and solve and make this say x equals. I don't have to factor. If I had x squared plus 5x, these x's will never combine. You're going to have to solve by factoring. But since I only have x squared here, I can solve by getting x by itself. So I have minus 4. Minus 4, you get 85. Square root it, square root it. Don't forget the plus or minus sign and the square root of 85. On the test, this answer will be much nicer than the one I gave you. So know that on the test it'll be much nicer, and it'll be easier to check your work for parts B. And to check your work, all you have to do is plug the x in and make sure that it works out. Just plug it back in. You can plug it back into the original equation. Make sure that it works out. Number 7 says, which is the only solution? So for this one, we said, hey, since it's a plus and they're both the same base log, I can multiply these two together, 5 times x, and write it as 1 log. Then once I have it here, I can know that this is the base 10. I can change it to exponential. 10 to the second power equals that. That's what I did here. 10 squared is really 100. That's what I did. Divide by 5, x equals 20. Now to check my work, how does this make sense? Put a 20 in this place, right? When I have this and this, I can multiply those. That makes 100. 10 to the second power is supposed to equal 100. Yes, it does. 100 equals 100. There's my show check work. All right, number 8, which are all the solutions for this one. So here, I go ahead and I say again, since it's subtraction here, I can say this right here divided by that. They're both this log base 4. If that's not log base 4, I can't do this. But since it is, I can go ahead and smash that together and divide those two. 16x divided by 2 is 8x. Again, right here, I can change to exponential because I have it as 1 log. Notice it's just 1 log over here. So I can change to exponential really quick. And so 4 to the 5th power is really 1024. And that equals the 8x. Divide by 8, and you get 128 for an answer. Number 9, I cannot change this to log form the way that it is right now. And the reason I want to do log form is because I know my x is up in the exponential. So there's got to be a way to get that down. The only way to get that down is by doing log form. So here, I go and I say, well, I can't do log because there's a 7 that's attached to this number. In order to change it to log, you just have to have some number to some power equaling some number. So you can't have anything extra out here, times or plus, on this side. So you got to move that over first. So how do I get rid of that 7? Divide by 7. Boom, it's gone. Divide by 7. And now I get some number to a power equaling another number. Now I can change it to log form. And so when I change it to log form, I go, wait, I can't do this problem in my calculator. It doesn't use the log 1/3. But what I can do is change a base formula. And then I put this in my calculator. When I put that in my calculator, I get this approximation, which is right here. I then divide by 4, and I get this as my answer. All right, number 10. Number 10, right away, it is just some number to a power equaling another number. You can change the to log form. Once I do log form, you can change a base, use your calculator, boom, that problem should be very straightforward. There is another way we can do this one, and the same with number 9 if you want to do this. I'll show it to you. Remember, you're allowed to log both sides. That might be something that comes in handy later on when I get higher level math. So I can log both sides. That's fair to do. The reason I can want to log both sides is I can bring that x out of the exponent. That's a trick that pulls an exponent out, is if you log. So log is very useful for getting variables out of the exponent. Now, what is this x doing, or what is this log of 8 doing to the x? It's multiplying. So if I divide this side by log of 8, that cancels out. Then I divide this side by log of 8. And again, I get x equals log of 97 divided by log of 8. And if you look, that same thing is written right there. And that's going to, so when I put this in my calculator, it'll be 2.2. Remember, in your calculator, you hit 97 log, divide, 8 log, and then hit equals. You have to hit that equals after. Number 11, the word problem, the concentration. It's a word problem, but basically it gives you the formula. All you have to do is plug in the H plus, the variables that they give you, and solve for the pH, which is the unknown. And it's very straightforward. I hit this number in my calculator, I hit log, and then I hit the negative sign, and boom, I should get 5.5. Number 12, I go ahead and for this one, I make these guys both become base 2s. I want them to have both base 2. So I know that 64 is 2 to the 6th power. And then I know 256 is really 2 to the 8th power. When I have power to a power, I have to multiply, so that means I have to distribute the 6, so it becomes 6x minus 12. That's where this came from. Since the bases are the same, since both they're 2, I know 2 to the 8th. This has to be 2 to the 8th, but this isn't. This is an equation, so I know that 6x minus 12 has to be equivalent to 8. So I want to know what x, when I put x in here, would make this whole thing become an 8. So I got to solve for that. So I make 6x minus 12 equal to 8. I subtract the 12, or add the 12 to both sides, and divide by 6, and I get 10/3. Alright, the last one, 13, it should be very straightforward. NERT, the only thing you need to be careful of, they give you the initial. E is a number. They give me my rate. They give me my time. Make sure you change the rate to a decimal. The rate was 3.5%. You move the decimal 1, 2 times, so it becomes 0.035%. That is what is written right there, not the percentage. And I times that by 9. That's how many years from 2010 to 2019. I times that by 9. I then put that in my calculator. I then hit Shift and E, so that takes E to the power of whatever this is. I then take that number and multiply it by this, and you should get the 42,000. I hope you go over this review a couple times. It's very similar to the test. Have a good night, and I'll see you tomorrow.